Hello Year 9s. We're going to have an introduction to the light box. The light box is a device that allows us to show a beam sometimes called a ray, a beam of light, or a broad beam of light, a narrow beam called a ray, or a broad beam of light. We can see we can see parallel rays, or we can watch divergent rays, and we're going to have a look at that. Each of the light boxes that we have got a number on them, and they identify which one belongs into which one. So the light box is divided into two parts. You've got a top tray or layer, which has the parts that we want, and the bottom layer, which has the actual light box, and we need to be careful to set this up. Now this is an electric, it requires electric source to use it, so we're going to plug it into the DC. We've got a power pack here, also has a number on it. We've got a power pack set to 12 volts and DC. 12 volts and DC is what we're looking for, and at the moment it's off. So now we plug it in, and we switch it on, then we turn our power pack on. Our power pack is now on, and we can tell that by the light that is there. We have a globe in there, that's a halogen globe, and it gets quite hot, so we don't want to have it on any longer than what we would normally do. With the light box comes two slit boards. The slit boards, as you can see, one of them has beams or narrow beams called a ray, and one of them has a broad beam, and it has 4 slits in it here. So you've got 2 of those, you've got a light box, you've got a power pack, and you're ready to go. What we want to do is to investigate some of the properties of light and see what we can do with the light box. Now, first thing we can do is identify, what we'll do is we'll go back a step, turn that off, we'll identify the various parts that we're going to use. The first part we're going to use, this is called a flat mirror on a stand. And it's a flat mirror because it's just like a normal mirror. It just sits flat. Just sits flat on its stand. There's no curve, there's no nothing. It's just a flat mirror. So this is a flat mirror on a stand. What we have here are concave and convex mirrors. Now the concave, the easiest way to identify one is that the cave goes inwards like a cave. So the other side is convex when it reflects back out. This is concave. And we have the same here. This is a mirror, slightly different. Circular part, arc on it, slightly different. But again, one side is concave and the other side is convex. They're concave and convex mirrors. Now we have the prisms that are on here. This one here is a concave prism. Now when light passes through from one substance to another substance, it changes speed, and that's called refraction or bending. So the light will bend when it moves from one substance to another substance and then back out again. So we will investigate how it goes into a concave prism. That's a concave prism. This one here is a convex prism. Notice it's convex. And when the light will pass from one substance through there and then will come out the other side, it will refract. It will refract. Now these prisms here, and these have got a holding handle on them, this is a rectangular prism. And the light will pass through, again changing speed, it will bend or refract away from the normal. The normal will be considered the 180 line coming in, a normal straight line coming in, and it will either bend away from the normal or bend towards the normal. And we will have a look at how that occurs. Rectangular prism. This one here is an equilateral prism, equilateral being three sides, 1, 2, 3, three-sided of equal length. That is our isosceles. That is our isosceles triangle. Two sides are equal, one side is not. And this is our equilateral, where three sides are of equal length. My apologies for that. Again, when the light comes in from the normal, it will refract, and then on the way back out, it will refract as well. So our equilateral triangle. This is a circular prism, and again, here's our circle. It's a half circle, but this is our half circle or a circular prism. And we have our convex prism. Again, convex prism there, and that is about it. Oh, here we go. This one here, we've got a scalene triangle. It's got the end of it broken off there. Scalene triangle where no sides are equal. And again, we will use it to pass light through and to investigate what happens with it. Now, our task for this prac is to just become familiar with the light box, its equipment and how we use it and what it shows. So that's what we're looking for. So as a result of that, in your prac sheet, there won't be an aim as there is normally, just a little bit of theory here. A light box has a slit that allows light from a globe inside to then come out in wide or narrow beams. A very narrow beam is often called a ray. So apparatus is the light box and the power pack. Now what you're going to do is, in the top layer, I've identified those main features, and what I want you to do is either using your book or using online, you can draw each of those, and this is on your sheet. Flat mirror on a stand, concave and convex mirrors. Now these ones here, concave and convex. Remember that cave goes in. Concave and convex lenses. A lens is which it passes through. A lens, like a lens in the camera or a lens in your eye. Concave, that is a convex, and this one is a concave. Various prisms. Rectangular prism. You can see it's 3D. Rectangular prism. You've got semicircle prism. And you've got the ellipse. Your ellipse prism here, and you have your equilateral triangle. See if I can get it right this time. Equilateral triangular prism. You have your isosceles triangle where two sides are of equal length and one is longer. Isosceles triangle, and your scalene triangle. Again, no side is of equal length to the other side. Scalene triangle. What I'm going to want you to do, I'm going to demonstrate now, one, how we set it up, and then I want you to draw these various ones here, and I'll go through and show you what they are. Right, we've got it plugged in, we have it plugged in, we've got it turned on, and you can see that the globe is in there and it comes out this end. That is our parallel end, and here we have our divergent. Now diverge means to move out from a point. Converge means to move into a point. So you can see here that we've got a divergent beam. It's a wide beam. And here we have our fairly straight one. These two slit boards that I pointed out, they fit across in front of the lens. And what we have here, I might just turn off some lights. Just see if we can get a bit more. Is that still looking all right? Okay. So we can see here we've got a beam or narrow beam, sometimes called a ray, coming out from there. When I turn this upside down, put it in there, you'll notice we've got 3 parallel rays coming out. 3 parallel rays. Now these can be put on various parts here, and you can get various effects. What we're going to see here on this end here, this is a divergent beam, meaning that it diverges from a point outwards. And you can see how this comes slightly out from the point here. And with this slit board here, you can see how these 3 rays are actually diverging or moving. You can see they're out here and then they're in here. So they are diverging all the way out. This one is a divergent wide beam. You notice it starts here and then it ends up wider here. Divergent wide beam. And this one is divergent 4 rays. Divergent rays. Start here and they've ended up. They just get wider and wider. Divergent rays. So let's have a look at what you're going to draw. An example in your book. Number 1 is a broad beam. So we'll take this. We'll take this, and a broad beam. A beam is the wider one. A broad beam. So you'll put that in there. And in your books, you're just going to, with the light box, simplest way is to just draw it as in a cross-sectional view, just draw it like that. You'd probably use a mirror, a ruler, which would be better. But here we've got a broad beam. Second one is a broad diverging beam. A broad diverging beam to go out. There we've got a broad diverging beam. That's fairly simple. Now a single light ray, there, just a line, you can see it here. And then we have a large ray. There, a large ray, there's a wider beam of light. You can see what that is as I'm moving it around. You can see that that is parallel. Right. A large diverging ray, which is this one here. You have a diverging ray. It starts from here and just diverges out. Then next one is 3 parallel rays. 3 parallel rays. And we have 3 parallel rays, which you can draw as 3 parallel lines. Then 3 diverging rays. Diverging, of course, meaning to go out, and you can see here 3 diverging rays. Then I want to use the second one, and we're going to get 4 parallel rays. We have 4 parallel rays, and then 4 diverging rays. 4 diverging rays. So there you're going to draw those, pencil, or should you wish to, you can go online and draw shapes in a Word document. That's fine. So I'll put the lights back on and we'll have a quickly summarise what we've done. And let's just turn this off so the globe doesn't overheat. Let's have a look at what we've done. We've had a look at our light box, and the light box has a top layer in it. The top layer has various prisms that allow light to move through, but as light passes from one substance to another substance, it changes speed, so therefore it refracts or bends, as it's sometimes called. So these prisms are all here, and we've named them. This is a convex prism, this is a concave prism. This is a convex and concave mirror. This is another convex on the outside, concave on the inside mirror. This is your elliptical prism. And this one here is just a flat mirror on a stand. Flat mirror on a stand. They all fit in there. They all have a spot in there, and you know that when you put them back in, you know how many you've got. We also looked at our light box itself, which is starting to get warm. Light box consists of a globe and a series of doors that allow us to shine light out here, and we can move the globe further and closer as we need to, with the lens I should say, further and closer as we need to. When we're putting that back in, this goes back in here gently. We have our two slit boards which have a broad beam. They have a narrow beam, sometimes called a ray, that has 3 slits in it, 3 rays, and this is 4, and they go in here as well. So just a quick introduction to the light box. Of course, this goes on top of it, each light box. It'd be helpful if I did that properly, wouldn't it? If I put it in the right way. There we go. Gently, that goes in there, and that's packed back up. Our power pack comes off, and when we put the power pack away, we roll it around the front here. We snip it under there, and that goes on the trolley like that, packed up like that. So we've had a look at our light box. We've had a look at the light rays as they come out, whether they're parallel rays or whether they're divergent rays. And what you're going to do is do a sketch or download a shape, use Microsoft Draw. You're going to do each of these, right? You're going to do these ones that I mentioned, and also the rays as they come out and what I showed you. So there it is, just a quick introduction to the light box. And you can get that done as soon as you can. Thank you.